Chalo. Question number 2. A uniform rod of mass m and length L rests on the two supports. A ball of mass small m is equals to m by 3 is being placed at a distance of L by 8 from the center as shown. Find the reaction at the support center. Here is one force. Here is one force. This particle of mass small m is kept distance of L by 8.
Yes.
Isn't it? So now if I write all the forces beta, so if this one in the diagram, if you see it very carefully, what is the distance of this one beta? This one is your L by 8 and this one is L by 4. So obviously
Yes,
this
sir.
distance is also how much?
L by 4.
This one is also your L by 4. L by 8 and this one is also your L by 4. So if I take all the forces right now acting on the A, this one is B, this is center C. Okay, center C weight will be acting in the downward direction. So let me
Yes,
draw
sir.
the diagram for this one. So from center, one force will act. That is nothing but of your weight, isn't it? So here there is one more mass which has been kept. That is also acting in the downward direction. One reaction force is somewhere here. This is acting in the upward direction. One more reaction force is somewhere here. That is also acting in the upward direction. Okay. So if I write that points, this distance is how much for me? L by 4. This is your center C. The weight of the body will be capital M into G in the downward direction. This is small mg in the downward direction. This is the reaction of your B. This is your reaction of your A. Anna?
Yes, sir.
Now the distance from center to this distance is how much beta? L by 4. Anna? The distance of small m
Yes,
is
sir.
kept at distance of your
L
L
by
by
8.
8. Isn't it? And this distance will be equal to how much beta? See here. If this is L by 4, L by ఇది కూడా L by 4.
Yes,
L
sir.
by
L by
4
4.
half ఇది కాబట్టి this one is also L by 8.
Yes, sir. L by 8.
Isn't it? So all
Yes,
the
sir.
forces are clear now. Two forces are on up, two forces are in the down. So since rod is in rotational equilibrium, since the rod is in rotational equilibrium, so what is the condition? First, write all the forces for translational. Sum of all the forces and y-axis must be equal to 0. Ante RA plus of your RB must be equal to all the downward forces capital MG plus of
Plus
your
small
small m
mg.
into your G.
Yes.
Small m value is given how much for me? M by 3 kada?
Yes, sir.
This one is mg by 3 plus of your, sorry, this is your mg plus of your, this one is capital M by small
By 3 into G.
mg into G.
Yes.
అంటే ఎంత అవుతుంది? 1 plus 1 by 3 is 4 by 3. 4 by 3 times of your M into G. This is your
Yes,
RA plus of your RB. This
yes,
is my
sir.
equation number 1. Now take the talks about your point B. So this is your point A. This is your point B. Okay. So I'm taking the B as a reference, but you can take anything as a reference. That's not a problem. So torque about B. So sum of your all the torques about your B must be equal to 0. First M force వచ్చేసి RA, isn't it? So
Yes,
RA
sir.
about 0.4. This you take it as reference now. A is how much distance from the B beta? This is L by 4. This is L by 4. So that
By
will be
4.
L by
Yes,
2.
sir. Yes, sir.
So that will be equal to your RA into your L by 2. That must be equal to. This is only the one force acting upward. These two forces are in the downward direction. Mg, this distance is nothing but L by 4. Antena?
Yes,
Small
sir.
mg by your 4. Antena?
Yes, sir.
ఇది ఎంత అవుతుంది? mg, small mg, ఈ distance ఇక్కడ నుంచి ఇక్కడ వరకు ఇదంతా L by 8. So if I'm writing that one right now, this one is your mg into your L by 4 plus small mg into the distance of this one is your L by 8. This is my equation number 2. Antena?
Yes, sir.
So how much I'm getting RA beta? Anything is getting cancelled in this one, you see? This L, this L, this L gets cancelled. This
Two,
is ones, this
ones,
one
twos,
is two fours.
yes,
The reaction of your A will be equal to your how much beta? Mg by over 2 plus of your small
G by 4.
mg by over 4. Antena? So that is equals to your mg by 2 plus this one is nothing but equal to how much beta? Small m is nothing but of your capital
Mg
M
by
into
M by
3
3.
by 3 into
3
4.
into 4, 12.
Avuna kada? This will
Yes, sir.
become for me mg by over 2 plus of your this one is your mg 3 4s are 12. Avuna
Yes,
kada?
sir.
So
Yes.
mg is common. So this will be equal to how much? LCM is 12. 12 minus 2 for like 4. So
Mg
yeah, the
plus 6 mg, sir. 7 mg
7
by
mg.
12.
Yeah, 7 mg by your 12. So this will be the reaction force of your A. Avuna kada?
Yes, sir.
So this is your RA. We already know that RA plus RB is 4 by 3 times of
Yes,
mg.
sir. We can just
So
substitute.
from this one, I can get the value of RB. So from equation 1, I can write from equation 1, RB is equals to 4 into mg by over 3 minus of your RA. No? So it is
Yes,
equals
sir.
to 4 into your mg by 3 minus RA value ఎంత వచ్చింది? RA value is 7 mg
7
by
mg by
12.
12.
So it is a 7 mg by over 12. So this will be equal to how much for me? 4 by 3 minus 7 mg by 12.
Sir, 4 mg minus. Uh, Sorry, not 4 mg, sir. 1 minute. Sir, 16 mg minus 7 mg by 12, sir.
అంటే ఎంత వస్తుంది?
9 mg, 9 mg by 12.
Yeah, it is 9 mg by over 12. అంటే ఇది ఎంత ఇంకా పోతుంది కదా? 3 3s 3 4s.
Yes,
అంతేనా?
sir. Yes, sir.
అంటే this will be equal to 3 times of your mg divided by your 4.
4. Yes, sir.
Isn't it? So the reaction
Yes, sir.
forces will be equal to how much beta? So the reactions it supports, the reaction it supports will be equal to how much? RA
RA
is equals to
7 mg by 12.
7 mg by over 12 and RB is equals to how much?
3
3
mg.
mg by over 4. Okay, na? Got it?
Yes, sir. Sir,
Okay.
once can you take it back to the first page? Sir, before this, sir, a question. Sir, before this. Okay, sir. Thank you, sir.
Chalo. Keep the next heading beta. Moment of inertia. Moment of inertia. Represented by letter capital I. In Newton's laws of motion, whatever is the role played by mass, the same role is played here by your moment of inertia.
Yes, sir.
Okay, beta. Moment of inertia is depending on the mass as well as the distribution, how we are distributing the mass of that one. Okay, so moment of inertia depends on moment of inertia depends on the mass, very important beta, depends on the mass as well as what, the distribution of mass. the distribution of mass. Distribution of mass means from axis ఎంత దూరంలో ఉంది, from the
Okay.
axis how
Yes.
much distance it is there. Okay na?
Yes, sir.
Isn't it? Is it uniform or non-uniform? దానిపైన కూడా depend అవుతుంది. It's not only depending on the mass, it is depending as well as on the distribution of your mass particulation. Like say for example, for a point masses, if I'm talking about your point mass, okay, ఇది మన axis ఉంది అనుకుందాం, ఇది axis of your rotation, like axis of your fan. Okay, so this one is your axis of rotation. ఈ యాక్సిస్ నుంచి ఈ పార్టికల్ ఇంత దూరంలో ఉంది అనుకుందాం. దిస్ ఇస్ పార్టికల్ ఆఫ్ మాస్ m and this is your r. So moment of inertia is nothing but that point mass into perpendicular distance, into what? Perpendicular distance from axis of rotation, from axis of your rotation, from axis of your rotation whole square. Okay, so what is the moment of inertia? I is equals to point of mass into the perpendicular distance from the axis of rotation whole square. That means
Sir,
I
you
values
told
will
right,
be
sir.
equal to how
ML.
much for me? Yeah,
Said
I
right, sir,
is
ML.
equals to for this one, I is equals to point mass ఎంత తీసుకుంటున్నాం మనం m. So this will be equal to your m into perpendicular distance is square. So I is equals to your m into your r square. Okay na?
Yes, sir.
This is for your 1 point mass I have taken. In the same way, for a system of your particles, if I'm writing for a system of particles, for your system of particles, and same from the axis of rotation, this is your axis beta. From this axis particulation, if I'm taking n number of your particles connected to this one, to say for example there is a one particle here which is of mass m1, which is the distance of r1 particulation, and there is one more particle here right now, this is your mass m2, which is the distance of your r2. There is another particle of mass somewhere here, this is your mass of your m3, which is the distance of your r3. Then this one is somewhere here a particle, this is your m4, and this is a distance of your r4 particulation. There is one more particle here on kundam right now, this is say for example m5, this is the distance of your r5 particulation. Okay, and this one is your axis of rotation, this is your axis of your rotation. Okay, now how to write the moment of inertia beta? I will be equal to your how much for me? I is equals to this will become for me m1 r1 square plus of your m2 r2 square plus of your m3 r3 square plus so on up to n number of particles. And I can write
Yes.
this one as I is equals to summation of your m into your r square. Okay na?
Yes,
Summation
sir.
of your m into your r square particulation. Clear?
Yes, sir.
Chalo. Let me give you one small example. Like say for example, we have got three masses right now. This is your axis of rotation like this. Okay, and this is your horizontal distance. Okay, and here there is one particle of mass of your m. There is your another particle of this one of mass of your 2m, and here there is your another particle of mass of your 3m. Okay na? So we have got three particles, of masses m, 2m, and as well as of your 3m. This distance is L, this distance is also your L particulation. And what will be the moment of inertia of the system? This is your axis, so moment of inertia of the system will be I is equals to ఈ యాక్సిస్ నుంచి స్మాల్ m ఎంత దూరంలో ఉంది నాన్న, m into your L square
Yes.
plus the next one 2m, అది యాక్సిస్ పార్ట్ ఉంది కాబట్టి on the axis distance will be 0, అంతేనా?
Yes.
Plus 3m. 3m is how much distance from the axis? Again, it is a distance of your L. So what will be your answer? M into your L square plus this one will be equal to your 3m into your L square. So the answer will be equal to how much for me? 4m into your L square. So this will be the moment of inertia. Clear?
Yes, sir.
Let me take you one more example. Like say for example, if I'm talking about the moment of inertia of the system right now, like this, like we have got two particles of masses m and 2m beta. This one is your axis of your rotation. This is your axis of rotation, and somewhere on this one we are keeping the particle. Okay, this one is at a distance of, this one is of mass of your 2m, and this one is of mass of your m. Okay, and this one is the center of mass xcm. Okay, the distance between
Yes.
them is how much? Capital L. ఇక్కడ నుంచి ఇక్కడ వరకు total distance వచ్చేసి capital L. Okay, so two particles of masses m and 2m are being separated by distance of your L. Find the moment of inertia about an axis which is passing through the center of mass. This is your center of mass, and perpendicular to the line joining the 2 point masses, and perpendicular to the line joining the two masses part of a relation. Clear? This
Yes,
exactly
sir.
center card ledana, center of mass.
Yes, sir. Yes, sir.
Masses are different kabatti we need to calculate first the center of mass. So
Okay,
what is
sir.
the center of mass distance right now? xcm, you calculate it right now. So xcm will be equal to your, this is m1 into x1 will be equal to how much for me? 0 plus of your 2m into this one is nothing but of your L divided by your m plus of your 2m. ante kada, m1
Yes, sir.
x1 plus m2 x2 divided by m1 plus m2.
M1
So
plus
then
M2. Yes.
everywhere gets cancelled, so it is 2l by 3. So center of mass ఎంత వచ్చింది? 2l by 3 part of relation. Now can I
Yes.
calculate moment of inertia beta? I is equals to small m is the distance of your xcm square plus of your 2m. 2m will be equal to how much beta? This remaining distance will become how much for me?
L by 2, sir.
Minus of your xcm.
Okay.
Antena?
Yeah.
So
Yes, sir.
this one will be equal to your L minus of your xcm whole square.
I
So
forgot that
m
it's
is
not in
nothing
the
but
center,
m.
sir.
Yeah. xcm will be equal to 2l by 3 whole square plus this one is nothing but a 2m into L minus xcm is nothing but a 2l by
12
3
by
whole
3.
square.
Yes.
So this one is nothing but m into, this will become for me how much beta? 4 into L square divided by 9.
9.
Yes,
Yes,
this
sir.
one is L minus 12 by 3 is how much? So this one is your 2m
L by
into,
3, sir.
this
L
one
by
is
3, sir.
L by 3 whole square,
Yes, sir.
isn't it?
L
So
square
if
by
I'll
9.
simplify this one is 4 into m into L square divided by 9
9.
plus this one is L square. This is nothing but 2m into your L
L
square
square
divided
by
by 3
9.
square is nothing but 9.
9. Yes, sir.
Avuna kada?
6
So
ml square
what
by
is the
9.
answer right now?
So
Enta?
6 ml square by 9, we can get it as 3 twos are
2,
and 3
yeah. So it is a
threes are.
2 ml square by 3.
Yes, sir.
Got it?
Yes, sir.
I hope you got an idea how to calculate the center of mass for the given conditions.
Yes, sir.
Clear? Huh?
Yes.
Take one more question, beta. Let's say we are having three particles, each of mass, m, each of mass m are placed on the vertices of an equilateral triangle, of an equilateral triangle, of length L, of length capital L. Find the moment of inertia. Find the moment of inertia. Number A, about an axis, passing through, about an axis passing through. Number one, one particle and perpendicular to the plane, Okay, in that one, the second one, midpoint of the side of triangle, and perpendicular to the plane. And third one is center of triangle, center of your triangle and perpendicular to plane. Okay, so this is
Yes,
your
sir.
question. So read the question carefully first. This one is your triangle. Okay, so first read the question. Three particles of each of mass how much? Beta m. That means I'm having three particles. I'm having one particle here of mass of your m. We are having one more particle here right now of mass of your m. We are having one more particle here of mass of your m. This is L, this is L, and this is your L. Okay, and this is your midpoint. So this is the distance from this one. This is the distance from one vertex, and this is the distance from the another vertex. Antena?
Yes,
This is
sir.
the side L kabatti. This total angle will be equal to how much for me? 60 degrees. This
Yes,
total
sir.
angle will
60.
be equal to 60 degrees. This total angle will be equal to 60 degrees. Now if I resolve this L into components beta right now, so this will be equal to how much? Idi R, idochesi R, idochesi R. This is L kabatti, this will become for me cos, and this distance will become how much beta? Distance from this center to this point will become how much for me? L into sin 60. అంతే కదా. ఈ L ని లేకపోతే ఈ L ని రిజాల్వ్ చేసుకుంటే హియర్ ఇట్ విల్ బికమ్ హౌ మచ్ ఫర్
Okay,
మీ?
okay.
కాస్.
Yes, sir. Yes, sir.
అవునా
Got it.
కదా. సో దిస్ ఈస్
Yes.
యువర్ L part deflation, this is cos, and this will become for me sin.
Sine.
So
Yes,
this
sir.
is your L into sin 60 ఎంత? √3/2. అంటే it is
Yes, sir.
√3 into your L divided by 2. So I
Yes.
got the distance from this one. This is like say point A, this is like point B, and this is point C. And this one is say for example of your point D. This one is like say point D. So C
Yes.
to D distance ఎంత వచ్చింది? √3 into your L/2. ఓకేనా? సో ఈ
Yes,
డిస్టెన్స్
sir.
ఎంత? L/2. ఈ డిస్టెన్స్ ఎంత? L/2. Now read the question carefully better. We have got three particles each of mass m which have been placed at the vertices of an equilateral triangle of side of your how much for me? L. Antena? Find the
Yes,
moment
sir.
of inertia about an axis passing through. We need to calculate the about an axis passing through. Number one particle and perpendicular to the plane. One particle and perpendicular to the plane part deflation. That means that axis passing through any one plane beta. That axis is passing through any one plane. Axis is passing through your one particle and perpendicular to the plane part deflation.
Yes, sir.
So what will be the answer? ఏదైనా ఒక యాక్సిస్ ని ఏం చేయాలంటే నువ్వు you need to take it along in a particle. Like say if I'm taking this axis is passing through this one, first one. The moment of inertia because of A will become how much? 0. Then the remaining particle will be how much distance right now for this one? Can you tell me? Moment of inertia of the another particle will be equal to how much for me? About an axis perpendicular to the plane. అర్థమవుతుందా? This axis is passing through the M beta, or else
Yes,
you take
sir.
an axis which is passing through the point C. That means you need
Yes,
to take
sir.
an axis and keep it into the same, into the C అంటే it should pass into the phone right now. లోపల
Yes, sir.
పోవాలి యాక్సెస్, అవునా కదా.
Yes, sir.
సో
Yes,
ఆ
sir.
యాక్సెస్ నుంచి ఈ డిస్టెన్స్ ఎంత దూరంలో ఉంది? L ఉంది. ఈ యాక్సెస్ నుంచి ఈ డిస్టెన్స్ ఎంత ఉంటుంది? రైట్ నౌ L
L.
ఉంది. బట్ మొమెంట్ ఆఫ్ ఇనర్షియా బికాస్ ఆఫ్ ద C will become how much for me? 0. అవునా కదా. సో
Sir, because it's
ఫస్ట్ వన్ I can write here. Moment of inertia about an axis passing through your A. About an axis passing through any point bit. I'm taking right now here A, passing through your A, and it is perpendicular to the plane. Perpendicular to the plane ఉండాలి, అవునా కదా. అంటే మేక్ ఎన్ యాక్సిస్ పాస్ త్రూ యువర్ ఏ లైక్ దిస్. ఈ ఏ నుంచి యాక్సిస్ పాస్ అయితే ఇది లోపల పోతుంది, అవునా కదా. సో ఈ యాక్సిస్ నుంచి ఈ డిస్టెన్స్ ఎంత దూరంలో ఉంది? L. ఈ డిస్టెన్స్ ఎంత దూరంలో ఉంది? L. అంటే moment of inertia will become how much for me? I is equals to, because of that own axis it will be 0 plus next one is nothing but of your M into your L square plus M into your L square. So answer will come out for me how much? 2 into M into your L square.
L square.
వచ్చిందా?
Yes, sir.
అర్థమైందా? మరోసారి చెప్పనా?
Yes, sir. అంటే తర్వాత అంటే once you explain, right, sir, next page
ఇది చూడు,
లో
నేను ఏం చేస్తున్నానంటే ఈ యాక్సెస్ ని, ఈ పాయింట్ ని ఐఎమ్ టేకింగ్ ఇట్ టువర్డ్స్ ద పాయింట్ ఏ. సో డ్రా ఏ
Yes,
స్ట్రేట్
sir.
లైన్ విచ్ విల్ బి గోయింగ్ అప్ అండ్ గోయింగ్ ఇన్సైడ్. ఇట్లా
Yes, sir.
So you should assume an axis which is been passing through this one like this. And this line is right now like into the paper, not like the vertical what we are seeing. Okay, like from the roof to your ceiling of the room. Okay na?
Yes, sir.
అంటే ఈ యాక్సిస్ ఇంత దూరంలో ఉంటే ఇది యాక్సిస్ అయితే ఈ పార్టికల్ ఇక్కడ ఉంది, ఈ పార్టికల్ ఇక్కడ ఉంది. ఇక్కడ నుంచి ఇక్కడ వరకు ఈ డిస్టెన్స్ ఎంత అవుతుంది? ఎల్. ఈ డిస్టెన్స్ కూడా ఎంత అవుతుంది రైట్ నౌ ఫర్ మీ? ఎల్ అన కదా. లైక్ ఏ సర్కిల్, ఇది లైక్ ఒక సర్కిల్ ఫామ్ అయ్యి ఇది యాక్సిస్ సెంటర్ నుంచి ఉంది అనుకో, అప్పుడు అన్ని డిస్టెన్స్ సేమ్ అవుతాయి కదా.
yes sir.
అంటే ఇది యాక్సిస్, ఇది సర్కిల్ అనుకో, దిస్ వన్ ఈజ్ యాక్సిస్ పాసింగ్ త్రూ సెంటర్ ఇట్లా, అవునా కదా. ఇక్కడో పార్టికల్ ఉంది, ఇక్కడో పార్టికల్ ఉంది, ఈ రెండింటి మధ్య డిస్టెన్స్ రేడియస్ ఏనా? 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 ఇక్కడ కూడా రేడియస్ అంతే కదా. ఈ పాయింట్ నుంచి ఈ డిస్టెన్స్ ఎంత? ఎల్. ఇది కూడా ఎల్, ఎందుకంటే ఇది పర్పెండిక్యులర్ టు ది ప్లేన్ ఉన్నాయి.
yes sir. Okay sir.
Got it?
Yes sir.
So about an axis passing through A and perpendicular to the plane. So I will be equal to how much for me? 2 into your ml square. Second one, Chudu. About a midpoint of the side of the triangle. About the midpoint of the side of the triangle part of a relation. So what we need to do? We need to pass about an axis which is passing through the midpoint of the side of the triangle, and it should be perpendicular to the plane. And there should be an axis which should be passing like this. This is the midpoint of any one side, beta. This is the midpoint of any one side. This is the midpoint of any one side. Anagada.
Yes sir.
You need to make an axis pass through this midpoint. Okay, that means you need to keep a pen, like you keep your pen on the D. That will be the axis.
Yes sir.
Anagada. If laptop on the other laptop koda exactly point D kada no pen petto. ఆ పెన్ పెడితే ఆ డైరెక్షన్ అయితే పోతుందో దట్ ఈస్ పర్పెండిక్యులర్ టు ద ప్లేన్.
yes
అవునా కదా. అంటే ఏ ఇస్ హౌ మచ్ డిస్టెన్స్ ఎట్ ఎ టైం? L/2. B is how much distance from me? L/2. C is how much distance for me?
L/2.
C
is complete
complete distance కదా. ఇక్కడ నుంచి ఇక్కడ వరకు ఇదంతా వచ్చింది మనకు L sin 60 కదా, √3 L/2.
√3 L/2. yes sir.
అవునా కదా. That means an axis passing through D, an axis passing through capital D and perpendicular to plane, and perpendicular to the plane. So I will be equal to your m into L/2 whole square plus of your m into L/2 whole square. అంతే కదా. ఈ డిస్టెన్స్ ఇక్కడ నుంచి ఇక్కడ వరకు ఈ మాస్ L/2, ఈ మాస్ L/2, ఈ మాస్ ఎంత దూరంలో ఉంది? √3 L/2. So this will be equal to your m into √3 L/2 whole square. ఓకేనా. సో ఇది ఎంత అవుతుంది? ml²/2 ప్లస్ ml²/2 ఎంత? టూ ml స్క్వేరా?
yes sir.
అంతే కదా. 2ml స్క్వేరా? ఇది L స్క్వేర్, ఇది L². L/2 ప్లస్ L/2. ఇది ఎంత అవుతుంది? ml²/4. This one is m into L²/4 plus of your into L²/4 plus this one is your m. √3 is nothing but a 3m into L² divided by 4. Antena?
Sir, so starting we can actually, okay, yeah, now we can cancel.
Now we can ml²/4, ml²/4, ml²/4 common gada.
Yes
so
sir.
it is m into L²/4 is common. So this is 1 plus 1 plus 3 and then the 5 gada. 3 plus 1 4, 4 plus 1 5, and 5 into m into L² divided by 4. This will be your answer.
Yes sir.
Clear?
Yes sir.
Now third one, very important. Center of the triangle. Find the moment of inertia about an axis which is passing through the center of the triangle and perpendicular to the plane. That means now you need to keep your pen exactly at the center. That should be passing through the center. That means the distance from here to here is r, from here to here is r, and here to here is r. So now we need to calculate the value of r, nana. ఈ
Yes,
r వాల్యూ
sir.
ఎలా క్యాలిక్యులేట్ చేయాలి చూడు. ఈ డిస్టెన్స్ తెలుసు నాకు L/2,
Yes, sir. And we know 30
isn't
degrees.
it? And I also
Yes.
know that this angle is how much right now? 30 degrees,
Yes, sir.
isn't it? So I can calculate the value for r from this one better. So from triangle, for third one, from triangle, this is something like this kada. This is one, this is one, and this one. This one is 30 degrees, this is your r, and this one is your L/2. అవునా కదా? So cos 30 is how much better? How do you write from this one? Cos 30 is equals to,
√3.
this is your L/2 divided by r కదా,
Yes, sir.
అంతే కదా?
Yes, sir.
అంతేనా? This is 90,
Yes,
అంతేనా?
sir. Oh, yes, sir. Oh,
So r is equals to ఎంత? L/2 divided by cos 30.
yes, sir.
Cos
Now
30 ఎంత?
√3/2.
So this one is √3 divided by 2. ఇది వెళ్ళిపోయిందా? So
Yes,
this is
sir.
how much? L/√3. So
Yes,
r
sir.
value ఎంత వచ్చింది? L/√3. Constant every time. In
Yes,
equilateral triangle, the distance from the centroid to any one vertex will always be equal to how much beta?
L/√3.
L/√3. వచ్చిందా?
Yes, sir.
Now this axis from this particle అన్ని సేమ్, ఇది r, ఇది r, ఇది r. అంటే how
Yes,
many
sir.
particles I can write directly? I is equals to your m into your r square plus m into your r square plus m into your r square.
Yes, sir.
అంటే this one is 3 times of your m into
M
r
into
square.
R square.
That is
And R
equals
is
to
L.
3 into your mass is nothing but of your m into r is nothing but L by your √3 whole square.
3 and
This
3
will
will
become
get
for me
cancelled.
3m into L square divided by 3. 3 and 3 will get cancelled. So moment
ML
of inertia for this one will become for me m into your L square. Clear?
Yes, sir.
So I hope you got rough idea related to them, how to do them. వచ్చిందా?
Yes, sir.
ఇవి యాక్సెస్ కంపల్సరీ బాగా గుర్తుపెట్టుకోవాలన్న ఈ పాయింట్స్, లేకపోతే ఇబ్బంది పడతావు. ఈ ప్రాబ్లమ్ ని 1-2 సార్లు ట్రై చేయి అండ్ ట్రై టు ఇమాజిన్ హౌ యు ఆర్ డ్రాయింగ్ ది యాక్సెస్ పార్ట్ ఆఫ్ రిలేషన్స్. ఓకేనా?
Yes, sir.
ఓకే చల్. దీంట్లోనే ఇఫ్ ఐఎమ్ టేకింగ్ వన్ మోర్ క్వశ్చన్ బెటా, నెంబర్ బి అని పెట్టుకో దీంట్లోనే. సో ఇఫ్ ఐఎమ్ రైటింగ్ వన్ మోర్ క్వశ్చన్, ఇట్ గివ్ మీ ది ఆన్సర్ ఫర్ దిస్ వన్. మొమెంట్ ఆఫ్ ఇనర్షియా అబౌట్ an axis, about an axis coinciding with side of triangle, side of your triangle. This is the first question. And number 2, about median of triangle, about median of your triangle. Okay, so read the question right now again. We need to calculate the moment of inertia about an axis which is been coinciding with the side of the triangle. Side of the triangle ante, now you should take an axis about completely one side.
Yes,
Okay,
sir.
so I'll write here right now, number second one la number 1. Is the triangle? If it is your triangle right now here, this is your one side of a triangle. Now you take the axis somewhere here beta. Now you can take this axis right now here like this, which is passing through
Yes,
completely
sir.
one side.
Yes, sir.
నువ్వు ఇట్లా కూడా వేసుకోవచ్చు. You can
Any
take
side
even like
also.
this, no problem.
Yes, sir.
So we are having one particle of mass m here. We are taking one particle of mass m here. We are taking one particle of mass m here. So this is the axis. Now tell me what is the moment of inertia because of this A, this is your B and this is your C. A and B is passing through the same axis కాబట్టి moment of inertia ఎంత అయిపోతుంది?
0,
Zero
sir.
కదా. So
Yes,
yeah,
sir.
I is equals to
Only C.
m into 0 plus m into 0 plus remaining is m. ఈ డిస్టెన్స్ ఎంత వచ్చింది మనకు? Centroid distance
√3
ఎంత
L by
వచ్చింది? Yeah,
√3 L by.
√3 L by 2. అంటే this one is √3 into L by 2 whole square.
Yes,
అంతేనా?
sir.
So
Yes,
I
sir.
will become how much for me? 3 into
3
m
L
into L square
L square
divided
by
by
4.
4.
Yes,
వచ్చిందా?
sir. Yes, sir. Got it, sir.
Clarity ఉందా?
Yes, sir.
Now about an axis which has been coinciding with the side of the triangle. Next one is about a triangle, about a median of the triangle.
Sir,
About
ఇప్పుడు
the median of the triangle.
C will be 0, sir, and we have
Very
to
good. Now
take
yeah,
A
for the
and
second one, if I'm taking the triangle right now like this, the median means what? We are having one particle here, this one is C, this one is your A, and this one is your B. అన్నిటికీ masses small m, and this one is your small m.
yes.
So now this is an axis which is completely passing through this one. అంతే కదా?
Yes, sir.
So this distance is L by 2. This distance is your L by 2. This
Yes,
one
sir.
is your median. This one is your median. So what will be the moment of inertia, beta? I will be
M into
equal to,
0.
I will be equal to M into, this one will be 0 dini valla.
Yes, sir.
Plus remaining is nothing but of your M
M
into
into
L
L
by
by
2
2 whole
whole
square
square plus
plus
M
M
into
into
L
L
by
by
2
2
whole square. So ఇదంతా అవుతుంది M into L square by 4 plus M into L square by 4. L by 4 plus L by 4 is nothing but L by 2. And this will become for me M into L square by 2.
by 2. Yes, sir.
Okay.
Yes, sir.
See, in complete rotational mechanics is very important to identify the axis better. How do you find out the axis and perpendicular distance from it? That is very, very important for us.
Yes, sir.
Isn't it? So we need to
Yes,
first
sir.
identify the distance, and we need to identify how do you derive the perpendicular distance from the axis of your conditions part. Okay, now so
Yes,
same
sir.
thing is applicable for entire rotational mechanics. So concentrate on axis of rotation and perpendicular distance from the axis of the rotation. అది మాత్రం నువ్వు ఫుల్గా కాన్సన్ట్రేట్ చేయాలి. ఓకేనా?
Okay, sir. Yes, sir.
So that was about your moment of inertia definition. I hope now you got an idea how to do the problems related to this one.
Yes, sir.
You can do them కదా.
Yes, sir.
రికార్డ్ అవుతుందా?
యా అవుతుంది సార్.
ఎంతసేపు ఉంది?
సార్ ఇంకా అది ఏం రాలేదు సార్ మీటింగ్ టైం రిమైనింగ్ ఏం రాలేదు.
40 minutes కన్నా ఎక్కువ అయిపోయింది కదా? కాలేదు.
అవును కరెక్ట్ 40 minutes అయింది. ఓకే.
చలో. Next one is moment of inertia of rigid bodies. Moment of inertia of rigid bodies. Moment of inertia of your rigid bodies. Sunday, are you free, beta?
మార్నింగ్ సార్.
Afternoon, 2 to 5.
సార్ అప్పుడు ఎగ్జామ్ ఉంటుంది సార్.
సండే ఎగ్జామ్స్ ఉన్నాయా? మండే ఉన్నాయా?
కాదు సార్, అది ఓన్లీ ఒక్కటే ఒక రోజు, అంటే ఓన్లీ లాస్ట్ వీక్, నాట్ లాస్ట్ వీక్, లాస్ట్ వీక్ ఆర్ సంథింగ్ సార్.
ఓకే ఓకే ఫైన్.
క్లాస్ తీసుకుందామని సార్.
లేదు, చిన్న ఎగ్జామ్ ఏమైనా పెట్టుకుందామని, రివిజన్ రొటేషన్ థర్మోడైనమిక్స్ కైనెటిక్ థియరీ ఆఫ్ గ్యాసెస్ ఏమైనా ఎగ్జామ్ రాసుకుంటావు అని. లేకపోతే నేను క్వశ్చన్ పేపర్ పంపిస్తాను, అవి ట్రై చేయను సరిపోతుంది.
ఓకే సార్.
ఓకేనా?
ఎస్ సార్.
Moment of inertia of your rigid bodies, but some regular bodies గురించి మాట్లాడుతున్నాం. First one is nothing but a thin uniform rod of mass capital M and length L. Okay, so we are taking a rod right now like this. So this one is your rod. Okay, and this is the center of mass gravity. Then this will be the axis. Then
yes sir.
This will be your axis part. Now for this one, this will be what beta? X axis. Oh, no? This
Yes,
will
sir.
be your axis.
Yes.
This will be your z axis. This will be your z axis. Antena? So
Yes.
if I'm taking this one as an origin, this will be your x axis.
Yes.
So this is your x axis beta.
Yes, sir.
This is your y axis, and this one is your z axis. So if total
Yes,
length is, this will become for me L by 2. This will also will become for me L by 2. Okay. Then center
Yes,
of mass back out ICM. Avuna?
Yes,
So
sir.
center of mass beta. O is your center of mass. Moment of inertia about the center of mass for this uniform rod is m into L square by 12 beta. Then proof చేస్తాం తర్వాత, but right now you just remember the relation. That is very important.
Okay, sir.
Moment of inertia along your x-axis ఎంత 0. Moment of inertia along your y-axis is equals to your Ix is equals to your Iz, and that will be equal to your m into L square by 12. Okay, so moment of inertia of your thin rod when the axis is being passing through the center and perpendicular to the plane ante Iy or Iy or Iz will be equal to how much beta? Ml square by your 12.
Yes, sir.
Isn't it? About an
Yes, sir.
axis which is passing perpendicular to the plane part of a relation. Okay, so in the same way, if I am taking one more part of relation about an axis, these statements are very important beta. About an axis passing through, about an axis passing through end of your rod, and perpendicular to length, and perpendicular to your length. అంటే రాడ్ ఇప్పుడు ఇట్లా ఉంది, ఇది రాడ్ అన్నాను. Now the axis is somewhere like this. This is your axis, అవునా కదా? So this is your O, this is your 1. So moment of inertia about your this axis will be equal to how much? This one is also your 1. So moment of inertia about your this axis will be equal to your m into L square divided by 3 about one end. About
Yes,
one
sir.
end, point of inertia about one end. ఈ rod నుంచి ఈ axis if it is passing through one end, then the moment of inertia for this one will become how much for me beta? Ml square
Ml
by
square
your
by
3
3.
part of relation.
Yes,
Okay
sir.
now,
Yes, sir.
very important. We'll do the derivations of this one also, don't bother. But right now you
Okay.
see moment of inertia of a thin rod if the axis is passing through center is how much? Ml square by 12. And if the axis is passing through one end, the moment of inertia is how much for me? Ml square
Ml
by
square
your
by 3.
3 part of relation. Clear?
Yes, sir.
ఇవన్నీ చెప్పేసింటారు క్లాస్ లో.
ఎస్ సార్, చెప్పేసేస్తాను. చెప్పేసి
నెక్స్ట్ వన్
ఆ
ఈస్ నథింగ్ బట్
ఫిగర్స్‌లోకి వెళ్ళారు సార్.
ఏ థిన్ యూనిఫామ్ రింగ్. రింగ్ అన్న ఆర్ హూప్ అన్న ఒకటే.
ఎస్ సార్.
హూప్ ఆఫ్ మాస్ క్యాపిటల్ M and radius capital R. So now we are taking a ring beta like this. We are taking a ring like this. Okay, so if this is your ring and axis is been passing through the center, like this. Axis is passing through the center like this. Okay, and from here to
Yes.
here this is your radius. Okay, and this is your point O, center. This one is your axis and this one is your radius R. Moment of inertia for this one about the center of mass will be equal to m into your R square for ring. For the ring, if the axis is passing through center and it is perpendicular to the plane, which is perpendicular to the plane part of relation. So what is the condition right now? So axis is passing through center. This one is your axis. Axis is passing through center. Number one is number one. Axis is passing through center. And perpendicular to plane. అంతే కదా? An axis
Yes, sir.
exactly passing through center, not throughout the diameter. Only center నుంచి
Center. Yes,
pass
sir.
అవుతుంది. Something like Sri Krishna's chakra when he
Yes, sir.
uses on
Yes,
a
sir.
finger. So
Yes,
axis is
sir.
completely passing through center. The remaining body is completely passing through that one. So axis is passing through the center and perpendicular to the plane part of relation. Second
Yes,
one
sir.
is about diameter. About your diameter. That means this will be something like this. Okay, this one is your diameter total from here to here. Okay, So if it is passing through the center, like say this is your point O, moment of inertia about your diameter will be equal to half of that one above one, mr square by 2. Or else I can write id is equals to your, this one is iz by 2. This one is equal to your iz beta.
Yes.
Okay. So the moment of inertia about the diameter is how much? Iz by 2. Iz value ఎంత వచ్చింది? mr square. So it is mr square by 2. Okay na?
Yes, sir.
Then third one in this one, number C. This is your ring, and I am taking axis right now like this, right now like this, and another one is like this.
Yes,
That
sir.
means
X,
along your, this one is your z axis,
Z
this is your along x
Y,
axis,
X
and this
axis.
one is along your y axis. So
Yes, sir.
moment of inertia along your I axis or Iy will be equal to your m into r square divided by 2. But moment of inertia about your Iz will be equal to m into your r square. Okay. ఈ proofs అనే
Yes, sir.
చేస్తాను నేను. Okay.
Yes, sir.
Just try to remember first the diagrams and try to see how we are taking the axis part of your relation. Okay. So moment of inertia about x axis enta mr square by 2, along y axis enta mr square by 2, but along z
Yes, sir.
axis it is mr square part of relation.
Yes, sir.
Okay na?
Yes, sir.
ఇవన్నీ ప్రూవ్ చేశారా క్లాస్ లో?
ప్రూఫ్స్ ఇవ్వలేదు సార్, అంటే ఇట్స్ బెటర్ యూ రిమెంబర్ అని చెప్పారు సార్.
ఓకే ఫైన్. థియరం చెప్పారా?
విచ్ వన్ సార్?
పర్పెండిక్యులర్ యాక్సిస్ థియరం, ప్యారలల్ యాక్సిస్ థియరం.
యాక్చువల్గా ఇక్కడ వరకు చేశారు సార్, ఐ గెస్. అంటే టుడే దే ఫినిష్ విత్.
So I hope you got an idea related to this one, Vida.
Yes, sir.
Moment of inertia for a rod, if the axis is passing through center, is how much?
ml square by 2.
About one axis if I am taking?
Then it is ml square by 3, sir. That's one end.
ml square by 3. For example, this go. If I am taking the 3 rods like this, this is one rod, this is one rod, this is one rod. All of them are same masses, beta.
Yes.
First rod, second rod, this one is third rod, and this is a center O. So you have got 3 thin uniform identical rods, beta. Each of mass capital M. దీని మాస్ కూడా క్యాపిటల్ ఎం, దీని మాస్ కూడా క్యాపిటల్ ఎం, దీని లెంత్ క్యాపిటల్ ఎల్, దీని లెంత్ కూడా క్యాపిటల్ ఎల్, దీని లెంత్ కూడా క్యాపిటల్ ఎల్. Find the moment of inertia about an axis passing through your O. So I need to calculate the moment of inertia about your O. That will be equal to how much, beta? This is O అంటే ఇది axis కదా, which is passing through the center and perpendicular to the plane. అంటే for the first one it is how much for me? I1. Next one is nothing but of your I2. Next one is nothing but of your I3. అంతే కదా, ఈ axis నుంచి ఇట్లా రాశాను నేను. దీనిలాగా ఈ యాక్సెస్ నుంచి ఒక రాడ్ ఇటు, ఒక రాడ్ ఇటు, ఒక రాడ్ అన్ని ఒకటే ఆరిజిన్ నుంచి ఉన్నాయి కాబట్టి యాక్సెస్ ఏమో పర్పెండిక్యులర్ కాదు. ఓకే. సో ఇది కూడా పర్పెండిక్యులర్. డోంట్ అజ్యూమ్ దట్ దిస్ ఇస్ దేర్ ఇస్ అన్ యాంగిల్ అని. యు నీడ్ టు సే దట్ దిస్ ఇస్ ఎగ్జాక్ట్లీ పాసింగ్ త్రూ సెంటర్. అంటే ఇది ఎంత పర్పెండిక్యులర్ అయితే ఇది కూడా దీంతో పర్పెండిక్యులర్, ఈ యాక్సెస్ కూడా దీంతో పర్పెండిక్యులర్. సో యాక్సెస్ ఎక్కడ నుంచి ఉంది నాన్న? ఒక రాడ్ నుంచి వన్ ఎండ్ నుంచి పాస్ అవుతుంది. వన్ ఎండ్ నుంచి పాస్ అవుతుంది అంటే ఇదే కదా. one end నుంచి పాస్ అయితే moment of inertia ఎంత? ml square by 3 కదా.
square by 3, yes sir.
So this will become how much for me? 3 times of your m into l square by 3.
Okay, yes sir.
I1 same, I2 same, I3 same కదా.
Yes sir.
అవునా కదా. So that will be equal to how much for me? m into your l square. Got it?
Yes sir.
So I hope you got a rough idea related to your moment of inertia for the given conditions part of relations. Inka we need to apply for your parallax axis theorem. That will try to do it in the tomorrow session of your class. Okay na?
Okay sir. Yes sir.
రేపు మరి మార్నింగ్ వస్తావా లేదా?
వస్తాను సార్.
ఓకేనా? ఓకే. నేను కొంచెం లేకపోయినా కొంచెం కాల్ చేసుకో నాకు. ఎగ్జామ్ లేస్తాను. ఒకవేళ ఏమైనా లేట్ అవుతుంది అనుకుంటే బై ద టైమ్ యూ కమ్ ఎట్ 6:30 జస్ట్ గివ్ మీ ఎ రింగ్ వన్స్. ఓకే.
ఓకే సార్.
ఓకే చలో బాయ్.
థ్యాంక్ యూ సార్. బాయ్.